I hope all of you are doing well. And in last video of gravitation chapter, we have covered that Newton's law of gravitation along with some questions. I hope you got that video. And if you haven't watched, you can watch that video first. And in this video, I am going to cover the gravitational field. So in this lecture, gravitational field, we will know that what is gravitational field and how to find gravitational field, means we will do question also. Okay, so by now you know that if any mass is there, it will attract any another mass m1 m2, it will another any mass which is having some distance r between them, and they must be having some masses. Okay, with force g m1 m2 by r square. So any mass attracts another mass with this force, and that force direction will be along the line joining their center. Okay, so this will be the force direction if I am talking about this. Okay, so now question comes, what is gravitation field? Okay, so gravitation field is nothing but, you can say, it is a space where gravitational force can be experienced. Okay, so in this example, if I am talking about this mass m1, so if I'll say that up to it is a space around m1 where m1 will where the force due to m1 can be experienced, means where m1 is attracting another object. So it will be space around here. Okay, so that space where it can attract another object will be its field, and that field is known as gravitation field. Okay, so I hope you get the definition. Means if any mass you take, suppose this mass m is there. Okay, so the field around which it is attracting any another masses which is kept in this field. Okay, so this will be its gravitation field. Okay, so it will have a area where it can attract another object, or the area where another object will experience a gravitation force because of this mass m. So that field will be known as gravitation field. And this becomes very easy when you imagine Earth. So this becomes very easy when you take Earth as an example. So suppose this is our Earth. So it will have some mass of Earth me. Okay, so any object which is kept on Earth's surface, I am drawing it bigger. Okay, any mass which is kept on this Earth surface, it will be attracted by Earth, and because of the force value will be g, mass of Earth, mass of object, and distance between them. So distance you can take, suppose this is radius of Earth and it is kept at some height or a radius of this. So to be precise, I should write r plus re square. Okay, so Earth will attract every object which is kept on its surface with this much force, and it will attract in towards its center. Okay, so when we are discussing about gravitational field of Earth, means it is a space around Earth where gravitational force due to Earth is experienced. Okay, so it is a space, gravitational field of Earth is space around Earth where the gravitational force due to Earth is experienced. Okay, so gravitational field of Earth is easy. And actually we call that if any object is experiencing a force because of Earth, means gravitational force on any experienced, we name it as a weight. You know, weight is a force by which Earth attract. It is a force. Okay, weight is a force, and its unit is, or you can say SI unit of weight is Newton, and Newton with a small n, NEW Newton. Okay, so weight is a force by which Earth attracts any object. Okay, so now there is a task, how to find gravitational field. Okay, so gravitational field of Earth, if you want to define, it is nothing but gravitation force per unit test mass. What is test mass here? Suppose I have kept here m is my test mass. Okay. So gravitational force per unit test mass. So field of earth will be, what is gravitational force? This is the Fg. So I will write G m E m by, and basically because this r will be compared when you are comparing with the radius of earth, it will be very small. So you can simply write this G m E m by r square, r e square. Okay. So I am writing that same thing, r e square. Okay. So gravitational force per unit test mass. So per unit test mass, so it will be cancelled. Okay. So field value will be G mass of earth by r square. Okay. So this will be gravitational field. This is the equation for gravitational field. So you have to remember, and to be precise you can remember like this. So with the help of limit you can say test charge tends to 0 F net by n. Okay. So this is the same thing you are getting here. Okay. So this will be your gravitational field value. So remember, in case of earth it will be G m E by, sorry, r e square. Okay. So, and what you can say about this, there you can see there is a no term of mass. So gravitational field, if we are talking about earth, it will depends upon mass of earth and radius of earth. So it is independent of mass or test mass, you can say. Means gravitational field will be fixed for it will depend upon only on the mass of earth and radius of earth. It won't depends upon the, it won't depends upon the another mass. Okay. Now next we are going to find gravitational field due to some point mass. Okay. So gravitational field due to point mass. Now take a point mass. Some m point mass I have taken. Okay. So can you find can you write the field value for this point mass? This will be G m by r square, where r is the distance. Okay. So field is a area, so it is a distance from point mass. Okay. Means listen, field is a area. Okay. So if I'll make this much radius, so this will be r. If I'll make another radius, means I want to find field strength, means how much force you will experience when you are here or any mass is here. Okay. So here it will be some radius is different, or if I'll say, okay, so this radius will be different. Okay. So you can say r1 and r2. So field strength will vary according to radius. Okay. So you can say if radius is bigger, field strength will be less, because it is inversely proportional relation. If this becomes bigger, it will be less. Okay. So when you go further and further away from m, field strength will be reducing. Okay. But it will be always attractive. So this is mass m, and so it will be always towards its direction. Okay. That we know. Eg will be in this direction, means the field strength will be in this direction, G m by r square, if this distance is r. Okay. Now we will do some question that will make your concept more clear. Okay. So question is like this. There is a point A given. Okay. You have to find the gravitational field at A. So what was the formula? So gravitational at A, gravitational field value at A will be G m by, how much is the distance there? Okay. So this will be HA. Okay. So this is gravitational field value. If you want to find how much force, if a m mass charge, capital M mass charge is kept there, so force experienced by capital M mass charge because of m1, how will you write that? You know, that will be G m into m1 into m by r square. Okay. So means force will be field into that mass value. Okay. So this you can remember. So force experience will be the field value, gravitational field value into the mass value. Okay. So remember this point. Okay, so next question, same thing, you have to find gravitational field. Okay, so now I have question, similar question. Okay, there are two I think actually if you have seen my first lecture, same question I am taking, and at this point A you have to find the gravitation field value because of these two. Okay, so because of this charge, what will be field value? You tell me. It will be, its field will be towards this, and that value will be gm by a square. And because of this charge, its field value will be in this direction. Okay, so because of this field, they will always try to, the field will always try to attract in the same direction as the mass, this mass. Okay, so because of this, it will be same value. Okay, gm by a square, and this is also gm by a square. Okay, so now these are two different vector, and we know this is a equilateral triangle, so 60 degree. Again you can find resultant. Okay, so there are two vectors like this and 60 degree. How will you find resultant? So resultant formula, suppose you have two vector, I will say this is f, this is also fe, sorry, fg. Okay, so eg, sorry, so eg square plus eg square plus 2 eg into eg cos 60. Okay, this will be our f net, e net, sorry, e net. So eg square you can take common, so what will be left? 1 plus 1 plus 2 cos 60, and cos 60 is 1 by 2, so it will be 1 by 2 into 2, so this will cancel. Okay, so this will cancel, so it will be 1 plus 1 plus 1, it will be eg, so y square will be, because we are taking out eg square, so square will cancel, root 3. So eg net will be root 3 for this question. Okay, remember. And if you want to find force, you can multiply the mass, whatever they haven't given. If suppose mass is given for this, if they give m mass m, so if you want to find f net, so it will be eg root 3 into m. Okay, so this will be f net. Similarly for this case you can find. Okay, so there are two mass, m is given, 3m is given. Okay, so eg because of field, because of 2m will be in this direction, and that value will be eg because of 2, it value will be g 2m by a square, and because of this 3m it will be in this direction, g 3m by a square. Okay, so now they are at the same 30 degree, so you will write g 2m by a square whole square plus g 3m by a square whole square plus 2, same thing, into cos of 60. If you take root of this will be net value, and eg net will be, you can check your answer, it will be e root 90. Okay, or you can say gm g small m by a square root 90. You can check your answer. Okay, so this will be because of this, and same thing we will solve for this. Okay, so because of this m mass, it will be here, and what will be its value? gm by I think side I forgot to give, a you can take. Okay, square side a square, because of this it will be gm a square, and because of this it will be in this direction, so gm, what will be this length? If this is a, this is a, this will be root 2a, so it will be 2a square. So add them all. Okay, so this and this, you can get eg net, you will get because of this and this. How can you add them? This will be, okay, so same vector methods you have to apply. So how will you add? This is in I cap, this is in minus j cap, you can treat it like that, or you can treat these two as a vector which is right at 90 degree. So this eg square plus eg square plus 2 eg square cos of 90, so cos 90 will be 0, so root 2 eg. Okay, plus for this we wrote, for this what we have to do? Again we have to take component. So along this, what will be its component? gm to a square cos of 45, this angle will be 45, so what is cos of 45? 1 by root 2, and along this it will be gm to a square into 1 by root 2. You could have added that also. Okay, So if you add this and this, it will be again Eg by 2. So you can say Eg root 2 plus half, or you can say what is value of Eg, Gm by a square root 2 plus half. Okay. So this will be your field value at a point. Okay. So and all this question we have already done in the part 1 of this video. Just you have to write the field in this. Okay. If you want to write the force, you could have multiplied with the mass of this test charge which is kept on a point. Okay. I hope you got. And one last question that we did in last video also. If I'll give you a rod like this, okay, suppose a rod of linear mass density is this. Okay, this is linear mass density is lambda. Okay, so m by l is fixed. Okay, linear mass density. So if a rod of linear mass density means a uniform rod of linear mass density is given, same a point A is there, you have to find field strength at A. Okay, how will you find? In continuation, same thing will do. Okay, so we will take a small component here of mass dm. Okay, so for dm we will say that a dm mass is kept here. Because of this dm mass, what will be field at A, and then we will integrate by taking small dm on this rod, and we will integrate and we will find total field at A Eg. Okay, so dm can be written as, because of this dm by its length you can take dx. Okay, its length is dx. Okay, so dm by dx is lambda. Okay, so dm will be lambda multiplied by the dx, and you can write lambda equal to capital M by L. This is given. Okay, full length is given L, its mass is given as L. Okay, so dx. Now what I have to do, I have to write field because of small mass dm. If a small mass dm is here at some distance d, okay, I should have given distance here. So let's say it is a from this end. Okay, and you can say this is some distance x. Okay, for x we can let, okay, so x I will take from here also. Okay, so I am letting this as x. Okay, so I am letting this x distance is from a point. Okay, so it is like this. There is a d mass m and x distance away from a. So what will you write? Field, like gravitational field at a, it will be g dm by x square. That is the value of this, and this is a because of small mass dm, so I will say d. Okay, small field. Now I have to integrate. Okay, so if I'll integrate this small dm, I can get value because of this total m mass rod at point A. So same thing I go to do, but take care of integration limit. So it will be g dm x square. Okay, so limit will start, if my dm mass is here, what will be the distance A, so minimum limit will be A. If my dm mass is here, so what will be limit? A plus L. Okay, so this you have to take care. Okay, so after putting limit, you can solve this. So put value of gm, dm, small dm, m by L dx upon x square, a plus L. Okay, now you can solve this. So you will get gm, L will be out, so x minus 2 dx and a to a plus L. You will solve, it will be minus 1 by x. Okay, so integration, now you can put value. After putting value, you will get gm L. Okay, so it will be 1 by L, it will be minus 1 by a plus L, minus of minus will be plus by a, upper limit minus lower limit. Okay, so finally if you solve this, you will get Eg value equal to gm a L plus a. Okay, so this will be the value of field due to this total rod at point A. So I hope you got how to find field value, and if you haven't seen the last video, you can see. So thanks for watching. see you in the next video. There we will discuss about gravitational potential energy. And if you want, if you have any doubt, you can ask me in comment box. And if you want these notes, you can again ask in comment box. Okay. So in this lecture we covered how to find gravitational field and what is gravitational field, and same type of question I try to cover so that you can understand it better, in a better way. Okay. So see you in the next video. Stay tuned. Bye bye.